In this video, I'm going to demonstrate how to export images as three-dimensional NIfTI files from HistoloZee. This is very handy for sharing your images with other investigators who may not have HistoloZee installed or may not want to use it. So let's make a simple project with only one slide, just for demonstration. Actually, let's include 2 slides here. Okay. And so that we have some anatomical context, let's load the reference image along with it. Remember that since the slides were acquired along coronal sections, we must choose Set Orientation from the slide menu and Coronal Orientation. Let's get a quick initial alignment of our slices to the reference MRI image. So this is the approximate location. And clicking on our slices, we can flip them to match the MRI orientation. And let's bring our MRI down here. Zoom in. And let's view just the first one, get a rough translation, get a rough rotation. Why don't we do a bit of registration here? Full affine registration, turning off masking. So we're now registering the histology slide to the MRI slice. Let's do the same for the second one. Not perfect, but it'll suffice for this demonstration. Okay. So now we have a project with 2 slides aligned to an MRI image. Notice that each slice has thickness of 0.2 millimeters and a very small pixel size of 0.5 micron. How do we export this as a NIfTI image? This is done under the File, Export Slide Stack option. This is quite a busy dialog, but I'll try to explain in simple terms what everything does. The first part of the dialog lets us specify which view area to export in our NIfTI image. Again, you can choose a bounding box of all slides with which to bound your NIfTI image. You can choose a bounding box of only the visible slides. You can choose to export the current view coordinates or any custom screen coordinates that you choose. For this example, I'm going to choose a bounding box of all slides. Next, you choose what slide range you would like to export. I'm going to choose all slides, but you can choose to export only visible slides or any custom range of slides. Next, you choose the output image dimension of your NIfTI image, and I'm going to choose preserve aspect ratio, and let's choose to export NIfTI image with 1024 width. The output voxel size of the NIfTI image is automatically updated to match whatever width and height you choose up here. So in other words, to properly preserve the aspect ratio and physical coordinates, we need to have unequal height and width ratio. In this box, you can set the slice thickness in your NIfTI image. I note that it must be a multiple of the largest slice thickness that you have chosen in order to work properly. So in this case, all of our slices have thickness 0.2 millimeters. I'm going to choose a slice thickness of 0.2. And this option lets us account for variable slice thickness and spacing. This is very important if we have slices with different thicknesses or spacings. In other words, when we export the NIfTI image, when we export the stacked NIfTI image, that NIfTI image will take into account any differences in slice thickness or spacing that we have applied. Next, we select NIfTI image output volume and what format we'd like to output in. Let's choose color RGB and anti-aliased interpolation and a white background color. So let's choose this folder and say teststack.nifty.gz. And now I'm opening up that test stack image in ITK Snap. And voila! You can see that under the coronal view, we have our slices. You can put the RGB display on. And there it is. Now, under the Tools Image Information tab, we can indeed verify our image dimensions, voxel spacing, and slice thickness. 0.2. You might be wondering why we have this additional blank slide. Well, that's because in our reconstruction project, there is this blank space between the origin plane, the k=0 plane, and our first slice, which is represented here by a blank slide. And if we zoom into the other views, you can see the slides here. The most important thing to notice is that our physical coordinates have been preserved. So if I place the coordinate, the crosshairs on some location in the image, say right here on the granule cell layer, and zoom in, check out these world coordinates. Now let's go to that same image in our NIfTI file and try to find the same location. So it's about here, I think. Now let's load up the inspector here. You'll notice that the NIfTI world coordinates in Snap correspond exactly to the coordinates in HistoloZee. Very, very important when exporting your slide stacks with reference imaging to make sure that all the reference coordinates are the same.